points. We are going to finish up with implicit derivatives. See our first free response questions. We are going to talk about locations of horizontal and vertical tangents. Then we'll talk about the second derivative test and figure out those horizontal tangents if they're maxes and mins. And then we'll do our first free response question. Key to horizontal tangents are when your slopes are 0. Key to vertical tangents, that's when your slopes are undefined. If you have a denominator in a slope equation, it's as simple as your top will equal 0, you'll have a horizontal tangent, your bottom will equal 0, you'll have a vertical tangent. Okay? So let's just go. You got to be able to take the derivative. You got to be able to solve for it correctly. I'm going to show all the steps. After doing these enough times, you'll be able to check as you're going. You'll be able to potentially skip a couple steps, but don't skip unless you know what you're doing. Cool. Horizontal tangents. We had x equals 3. Vertical tangents will be at y equals 2. Now, here's the key. This is not your answer. 3, 2. Your answer will be the points. So you need to take these separately and plug it into the original. So I get 9 minus 18 plus 4 plus y squared minus 4y equals negative 9. This is negative 9, so I get to cancel that stuff, and I get to factor out. And I get y equals 0 and 4. Those are the y coordinates that go with the x coordinate of 3. Let's take that and plug it in. Some stuff. Move everything onto one side. So that's x equals 5, x equals 1. All right, so let's double check. My favorite thing about this unit is the ability of checking your work graphically using Desmos. X squared minus 6x plus y squared minus 4y. Equals negative 9. We got 3, 4. We got 3, 0. That looks right. Horizontal tangents. Then we got negative 2 or 1, 2. Yep, 1, 2, 5, 2. Ba-bam, 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 bam, 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 bam. Bam-a-lam. Cool, let's do it again. Probably should write a little smaller. Okay. I skipped the step of factoring out the dy dx. I did all at once. Hope you're okay with that. Cool. Make sure you know which one's which. The horizontal tangents will be when your slopes are 0, which means your numerator will be equal to 0. This is 2. Vertical tangents are going to be when your denominator equals 0. Y is 1. Let's plug in 2 into the original. 16. 64. Great. Great, Mr. Mester. Great problem you chose. 76. What? What? Gosh. What? 2, 4, 8, 16. 64. What am I doing? What am I doing? What's even happening? What are you doing here? Pay attention to details. If something's not going well, guys, you probably know better than I do that. You're not getting a nice answer. It's like, well, the problem's in the design of the problem. All right, let me subtract 64 first. And let me subtract 32, and that's minus 48. Now I got 8 and 6. Oh, Ace. Nice. You like the leaf blower in the background? It's fun. What number is that? Add to get negative 32, multiply to get 97. Makes sense. Yeah. Threes do. 13. What? No solution. How do I know that? I mean, you can look at the discriminant. All I gotta say is my bad. Sorry. Bad problem. Apparently, we're gonna get two horizontal tangents and we won't have a vertical tangent. I'm not gonna give you something like this in a quiz. You won't get something like this. Where did this problem come from? Seems oddly specific to not work, but let's see. Yeah, that's weird. It's like an x to the fourth on top of itself. Very much like an x to the fourth, but two horizontal tangents. That's it. Oh, that's a good start, guys. Everything's going really well. This is very easy. I mean, if you don't think about dividing by two here, then like we'll never think about dividing by two. If you don't think about pulling out a negative here, then we'll never think about pulling a negative. So we might as well do it. It's a good one because at least we get answers. No, we don't. This would be a plus. Jeez. I write a little note to myself. plus. All right. I think there's two vertical tangents and no horizontal tangents. Find out. 3 plus 2x. Yeah, look at that. I think that's the key to these problems is that like sometimes you have some and not the others. One, we want to find the x equals or when the y equals not the point. So divide top equal to 0. The horizontal tangents. Bottom equals 0. Gives you plus or minus 1. Right there. Look at that. Upside down, taking the back of your throat. X equals 0, y equals 1, y equals -1. Look at that. Cool. So we didn't find the points because they're too hard to find, but we found the locations. Tougher ones. Here's the tougher ones. Why is it tougher? Because after finding dy dx and what it's equal to, you will not be able to easily set the top and the bottom equal to 0. What do we do? Unfortunately, it's not going to be nice. The other one's going to be nicer. Let's start with the horizontal tangents. Going to erase all this work. You need space. unit space. Tangent is when the top will equal 0. The vertical tangent will be when the bottom equals 0. What the heck do we do here? Well, like, we got to solve for a variable and plug it back in. Now, this is not easily done. But I want to show you how it doesn't matter what variable you solve for. I'm going to solve for x here. Okay. And then what we do is we take that and we substitute it into the original equation. Now, when we do that, we need to do it carefully. Use parentheses. Wherever you see x, replace it with 3/2 y. Now, what do I want to do? I want to combine all my y squareds because I have all these y squareds. And honestly, I could multiply everything by 4 if I wanted to. Or combine them all. I'm going to multiply everything by 4 just because I think it's going to be easier. And I get -9 plus 4y squared, which is -5. And I get y squared equals 4, which means y equals plus or minus 2. Cool. Now, what's great about these, even though it seems harder, finding the points is actually easier. You get y is plus or minus 2. If y is positive 2, x is 3. If y is -2, x is -3. You can easily find those because you've already taken this and substituted it into the original. You don't have to go back into the original equation. If you do, you actually might get a point that ends up not satisfying this x equals 3/2 y. So, like, since you've already substituted it, you could just substitute this into x equals 3/2 y. If you solve for y, 3/2 x, you probably get the same thing. And I honestly don't want to do this, but I'll do it. Maybe it'll be a little bit different. Not same thing. Crazy symmetry. Yeah, look at that. 3, 2, -3, -2. Horizontal tangents. Vertical tangents, 2, 3, -2, -3. All right. Honestly, if you do one or the other, these questions take forever, huh? Yep. Get to distribute. Oh, horizontal tangents when y equals 0. Y is 0. Oh, hold on. So this is good. Like, this is kind of like where the previous questions on the homework led you. Y equals 0, you get 0 equals 2, which means there's no horizontal tangents because there's no points on this graph where y equals 0. So none. Vertical tangents are going to be when 3y squared minus x equals 0. Here's a great example, guys. There's so much noise going on. It's a great example of don't solve for y. Like, I do not want to solve this for y and get a square root, a plus or minus square root. But it's so simple. X equals 3y squared. Substitute back in. Get y cubed minus 3y squared y equals 2. I get y cubed minus 3y cubed equals 2. I get negative 2y cubed equals 2. I get y cubed equals negative 1. I get y equals negative 1. When y is negative 1, x is 3. Plug it back in here. You can actually plug it into the original and get negative 1 plus x equals 2, and you get x equals 3. So that's really interesting. Y cubed minus xy equals 2. And there's the vertical tangent of 3, negative 1, and there's no point where y equals 0. Great. Oh, here's another thing we can do with a second derivative. Talk about over or under approximations. All right. Neater. Divide everything by 2. Subtract x, divide by y. I think they wanted this to be a k. Sorry if that didn't make sense to you. 1/10. Divide by negative 3, multiply by a third. It's 90. So it's 89/90ths. Let's find the second derivative. Make an educated guess as to if your approximation's over or under. So here is where we're finally using a second derivative of an implicit curve. Because we know second derivatives talk us about curvature, whether a concave down or concave up. So how do we do it? We make sure we have the derivative, make sure it's simplified, then take the derivative of the derivative. You get d squared y over d of x squared. Slopes of the top times the bottom, you have to use the quotient rule, minus the slopes of the bottom times the top. All over the bottom squared. Now here's the key. You're plugging in the 0.31. 3 1.1 or 89/90ths. Like, you don't want to do that. No, 30ths. My bad. Should be close to 3. Plug in the 0.31. If you plug in the 0.31, you get -1 minus. Here's where you need to take your original derivative, dy dx. You know what it is. You could plug 3 1 into that. You get -3 times another -3. And you get -1 minus 9, which is -10. Okay. If you are concave down and you're using a tangent line, most likely your approximation is over the actual. Understanding the curvature of these implicit curves helps us. I mean, most likely is going to be true. Yep. What else can a second derivative tell us? Did I not put any second derivative tests? Oh, okay. I put more of that. So, I mean, I'm going to go to the last question and understand that if you know you have a horizontal tangent and you know the curvature, you could be able to tell whether your tangent is a max or a min. This point, because if you're concave down, concavity helps you understand, okay, concave down, horizontal tangent, it's got to be a max. Concave up, horizontal tangent, it's got to be a min. So, here, this equation has a horizontal tangent at -1, 1. If I looked at the slopes of it, which I did earlier, it's not equal to 0 at -1. That's the, whatever. Instead, let's just trying to talk about the second derivative test. I felt like I had more questions on this that had it, but it's here on the bottom. And then we'll do the free response questions. I do not want to take this derivative. Slopes of the top times the bottom minus the slopes of the bottom. This homework's brutal. Who made this homework? I made this. Slopes of the bottom, 6y dy dx minus 1 times the top. All over the bottom squared. Dy dx at -1, 1 is 1 over 3 minus -1, which is 1/4. Great. So I get 1/4 3 minus -1 minus 6 times 1 times 1/4 minus 1 times 1 over 4 squared. This is great, guys. This is fantastic. This is a fantastic problem. Gosh. That gives me 1. This is 3 plus 1, 4. 1 minus 3/2 minus 1, 6/4 minus 1, which is 3/2 minus 1, which is a half over 16. So I get 1/32. This curve's got to be concave up at negative 1, 1. Right? Barely. It's barely concave up. It looks like we changed concavity here. When is this equal to 0? Yeah, don't worry about it. If we have x equals 0 and y equals 1, like, I don't know. Like, what? That equals 0? It's not y equals 1. It's y equals 1.25. Whatever. All right, brings us to a key application of a second derivative. It's not easy to do a sign analysis if you have x's and y's because you'd have to do a two-dimensional sign analysis. Instead, sometimes what's easy to do is find a second derivative. And to figure out what it is at this point. Now, dy dx at 1, 3 would be 3 minus 3, which is 0. This makes a lot of sense. Because they're told, like, we have a horizontal tangent. A horizontal tangent when the slope's 0. So, boom, my slope is 0 at this point, 1, 3. Now, I just found that my second derivative is negative 3. What does that mean? At the location of a horizontal tangent, I know my function has to be concave down. We know that we must have a max. Okay, that's the second derivative test. It's an important thing to know that sometimes shows up on the AP exam. And where would it show up? On some free response questions. Hey, it's our first free response question. This is probably 3 of the 4 parts, but let's say I gave you this question on your test. Every free response question is worth 9 points total. This is an exact free response question from the past where you can earn 9 points. Here's the deal. The harder parts are usually worth more. You don't get partial credit just for showing anything. You get partial credit for being on your way to getting the correct solution. Let me show you what that means. There's a point on the curve near 2, 4 with an x-coordinate of 3. Use a line tangent to the curve at 2, 4 to approximate the y-coordinate at this point. Okay. Yo, you know what's great about this question? They already gave you the derivative. They said, hey, if you found the derivative of this, you would get that. Typically, a part A is find the derivative or show that the derivative equals this. They're not even wanting you to do that. They're like, hey, you just got to know how to use this stuff. All right, so we need to find dy dx at 2, 4. My cursor is really tripping out right now. Like, it's really slow. Really slow. I get negative 4 over 3 plus 4 times 4. So I get negative 4 over 6, 19. Oh, what? Are you serious? Great. You mean my tangent, y minus 4 equals negative 4/19 x minus 2. And we are approximating an x-coordinate of 3. So I'll get negative 4/19, 3 minus 2 plus 4. Great thing about free response, guys. Calculator ready answers are acceptable. This is totally fine. You would leave that. Is the horizontal line y equals 1 tangent to the curve? See, like, this is a great question. Y equals 1 would have a slope of 0. So do we have a slope of 0 when y equals 1? Well, we have horizontal tangents when x equals 0. I'm wondering if x equals 0, y equals 0, or y equals 1. When x equals 0, you get 3y plus 2y squared equals 48. Y is not equal to 1. Which means the line y equals 1 can't be your answer. So, like, this is tougher, right? This is so frustrating how slow this is. So, like, you have to explain stuff a lot for your response. So, B, my answer is like no. Why? Curve has a horizontal tangent when x equals 0. This does not occur or y cannot equal 1 when x equals 0 on the original equation. Something to the point of that. You don't even have to find what the y is. Though I think it's possible. But that's it. Part C, the curve intersects the positive x-axis at the point root 48 zeros. The line tangent to the curve at this point vertical. Okay, well, they're giving you a point. They say is it vertical. So part C, you should be able to say a vertical tangent, which you would write out. I'll write it out. You have to explain it. A vertical tangent is when dy dx is undefined. And that's when 3 plus 4y equals 0. That's when y equals negative 3/4, which is not when x is 0. So no. No. So it's really weird. Like, usually, I remember this question. This is from the previous year. Usually, you're going to like have to confirm things that are true. Here, they're just like, yeah, no, neither. I mean, we can look at the graph, x squared, which you wouldn't be able to do on the actual AP exam, which would have been nice, but no, they're not going to make it easy. So it's just this ellipse, and they're like, hey, y equals 1. Yeah, y equals 1. Yeah, no. Y equals 1 doesn't work. So the answer is no. And then squirt 48 0, which they said is on the point, which is where it intersects the x-axis. Is there a vertical tangent there? It's like, no, the vertical tangents looks like it's right here at 7, -1. No, it's not. It's going to be when y is negative 3/4. So when y is negative 3/4, right there, wherever that point is, which like they didn't ask you to find. It's not something I'd want to find either. I would not want to plug in negative 3/4 into the original. So like, free response sometimes is easier. You don't have to do as much as you would normally for me. What would I give you? Probably 1 point for the slope at 2,4. Probably 1 point for the approximation. Maybe 1 point for the equation, 1 point for the approximation. This is so slow. Horizontal tangent x equals 0. I would want you to plug in x equals 0 into the original equation and show that y doesn't equal 1. You probably need to talk about how no, this is not going to be the case, that when x equals 0, y isn't 1. If you actually found it, it's great. That's probably worth 2 points. This is probably worth 2 points, 2, 4, 6. And then the last part, which we'll talk about after next lesson, will probably be worth 3 points. You'd probably need to say that a vertical tangent, when dy is undefined, you either find that y equals negative 3/4 and you say no, maybe that's worth 2 points or 3 points. If you're wrong, you're probably not getting much points. Like if you're not getting the correct derivative, you could get a point for using your incorrect derivative correctly. If you are finding a horizontal tangent when x equals 0, if you said like yes for some reason, but you have like some work, maybe you get points. But usually you'll only get points if you're working towards the correct answer. All right, here's another question from a previous AP test. And we have our first show that the derivative is that, which is great. Like they want you, even if you don't take the derivative correctly, to be able to get part B and part C. So they know, they're telling you what you should be getting. You just have to get it. I'm literally going to close this off and I'll go back up. This is so frustrating. So, yeah. We take the derivative and we're going to solve for dy dx. We need to show that we know what we're doing. So some things you need to show are the product rule, maybe the distribution of 6 if you don't use the product rule like I'm using it. The derivative of 2 being 0, you don't have to show it, but just make sure you don't have 2 stays as 2. The correct solving for dy dx, probably showing minus 6y and minus 3y squared dy dx. You'd have things a little bit different order. You're then factoring out a dy dx. You're dividing to solve. And you're going to notice something. Like, oh, mine is different than what they have. Did I make a mistake? No. Maybe we can divide everything by a negative 3 on the top and on the bottom, or multiply everything by a negative 1/3. Now, if you do that, that becomes a positive 2y. This becomes a negative 2x. This becomes a positive y squared. And hooray, you got what you want. You're probably getting 2 points of this. One, making sure you have the product rule as well as your dy dx's. 1 point for then correctly solving algebraically for dy dx. Part B says find the coordinates of a point on the curve in which the line tangent is horizontal, or explain why that point does not exist. So you could say a horizontal tangent will be when your numerator equals 0. Your numerator equals 0 when y is 0. You plug that into your original equation, you get 0 equals 2. Oh, like I literally gave a similar one to this earlier, and you say, like, does not work. There's no solution to this. Therefore, there's no horizontal tangent, as there's no points where y equals 0. And then part C, vertical tangents. y squared minus 2x will equal 0. This is a good example of solving for the correct variable. I'm not going to solve for y. I'm going to solve for x. That way I don't have to take a square root. I'll take that and substitute into the original equation. I get 6 times y squared over 2 times y equals 2 plus y cubed. So give me 3y cubed equals 2 plus y cubed. That'll give me 2y cubed equals 2, y cubed equals 1, y equals 1. If y equals 1, x is a half. You could plug it back in. So you get 1 half comma 1. So, boom. Probably getting 2 points here. Probably getting 3 points here, 2 points here. 1 point for correctly setting the denominator equal to 0. 1 point for substituting, 1 point for finding the point. Let's go ahead and check it out, and then we're done. Not the best homework, if I'm going to be honest. Could have had more second derivative tests. I think I took some off. You won't have the ability to do this on the AP test. This is a no calculator problem. We have a vertical tangent at 1/2 1. Ba-bam. We do not have a horizontal tangent at any points. We are getting close to y equals 0. We never get there. Cool. All right, that's it. Free response question for your quiz on Friday. And free response for your test in the future.